Hello and welcome. Apologies for not being able to be there in person today, but COVID has dictated that I need to stay away from you all. My name's Luke Osborne and I'm the Energy and Emerging Technology Solutions Advisor for ECA. This presentation, entitled The Contractors Outlook for Zero Carbon Britain, will look at how wholesalers can benefit from our move to net zero carbon. ECA has been around for 120 years, supporting the electrotechnical sector, and on your screen are lots of the numerous benefits that we offer to our members. But obviously, you're not here to listen to that, but I just thought I'd mention that just in case. So, in recent months, we've all seen coverage of the fires burning across America and Australia, the severe flooding across Europe and the UK, and the severity of climate change are becoming increasingly regular and has even alarmed those modelling the impact of climate change, as these effects are happening much sooner than expected, thus putting pressure onto the governments to act swiftly and to bring forward intentions on how to reduce our carbon emissions. Unfortunately, our children are the ones who will be most affected and impacted if we don't act now, and I wouldn't want to see any of them put through the extremes that climate change will bring. Now, the UK may be well positioned to fare better than some other countries, but as we are already seeing, increased flooding, longer hot summers, icier winters will become the norm. Not to mention the risk to food supplies, climate refugees, and a distinct threat of increased military activity, as global geographic borders become pressed and resources become under threat. So what is industry doing? Well, industry is and has come together to influence government to make the right decisions and to put in long-term plans and strategies across multiple terms of office. We are part of Actuate and the Construction Leadership Council, and this is a collection of various organisations which has come together to put forward how industry can work together. 4 key policy areas, and this includes business recovery, building safety, climate crisis, and net zero carbon, as well as developing the skills needed by industry to be able to deliver what needs to be done. As part of this, ECA has put together an extensive guidance note for our members, highlighting the net zero carbon opportunities that they can be involved in going forwards. As well as the training and where to find the training and the different opportunities as they come. There's a few key focuses going forward, and a lot of this revolves around how our low carbon electricity network is developing. We are installing ever increasing amounts of renewable generation, and in order to combat some of the reductions in output due to weather, we can install increased amounts of renewable energy generation, such as solar PV and wind. We can increase the energy storage capabilities that are in the system, or we can maximise the energy efficiencies and the flexibility. Now, in reality, it's going to be a combination of all three, but with a particular focus on the last two. So increasing the energy storage capabilities and also maximising the energy efficiencies and flexibility. This is all highlighted in a recent report from BEIS in their transitioning to a net zero carbon energy system, which was published in June. So this links in with the concept of the prosumer, or the energy prosumer, to give it its full name. And this highlights the move from a single flow of energy into a directional flow of energy to and from a building. So the building's gone from just being a consumer of energy to now being able to generate and be an active component within the grid. And it's quite possible that this may become a new chapter in the next iteration of BS 7671, the wiring regulations, which will be released in spring next year. And if this is included, this will help to drive forward the adoption of lots of the technologies that we're going to cover. So this is an overview of the prosumer, and you can see it's a building incorporating many different technologies, and each of these has the capability to be monitored. So it's really important for a flexible energy system to be able to understand what's being used and when, and also what storage is available, what high demands are being put onto the network, and also what spare generation capacity is around. And so you have all these additional meters kind of attached from the generation, storage, and also where the devices are being used. And also you need some clever management on how this is going to be managed. And this is through a system termed as the electrical energy management system or the home energy management system, both. And, this provides the interaction for how the users can then interact through their phone to control their devices. I mean, we all know most people will probably use these apps for the first 3 weeks and then forget all about it. But to be honest, it doesn't matter. A lot of this will be controlled by machine learning, AI, whatever you may term it as. But in reality, how this functions won't have lots of individual meters. Instead, you'll probably start to see lots more equipment with these meters embedded, such as the ones you can see here. There's an air source heat pump and a battery storage system with embedded metering to enable the communication with the rest of the system. But you may start to see, as you can see in the bottom left-hand side, a HEMS ready consumer unit, so home energy management system ready consumer unit. So this is where each RC, CBO, etc. will have an incorporated energy monitoring equipment to enable the communication between all the devices. We already have additional plug-in components that can do this commercially, as you can see in the image in the center of the screen. But then there's also considerations in how all these things are connected. Many people are already using smart home equipment. Often it's plug and play doorbells, speakers, etc., etc. And they tend to work quite fine. They just work off the Wi-Fi. But in reality, most people change their routers every 2 or 3 years, and each time that happens, they need to change their passwords, as well as there being security issues, etc., etc. You can also have a mesh network. There's various options out there, and some of the equipment, some of the smart homes equipment already includes this and works on this kind of mesh basis. And this is where each device communicates with other ones and passes on the connectivity, thereby creating this mesh network. It has more advantages than a single point of contact, such as the Wi-Fi, but it can still be prone to communication issues. And as we go for more insulation, especially new builds, but in existing dwellings as well, lots of the insulation boards have foil backing, which is very, very good at blocking signals. So in which case, a hard wired connection is often more preferable, such as Cat 6 and Cat 7, and this makes it not foolproof, but less able to be hacked, but also provides much more robust connectivity. And there's a thing called Power over Ethernet, which makes use of being able to provide not just the data, but the power through these systems as well. We do come on to that shortly in the presentation. All this also links into further things that are propagating through our commercial and domestic buildings. I've already mentioned smart homes, but on the screen it just gives a bit of an overview of the different technologies that are being deployed by lots of our electricians at the moment. As well as the solar PV and battery storage, you've got all the hardwired entertainment systems, smart lighting, environmental control. This is becoming a big business as well. All these things are starting to link in with the fire and security, the electric vehicle charging, and also your blinds, shades, etc., etc., and obviously the smart interface for the cooling and heating. Now, I mentioned Power over Ethernet a minute ago, and as you can see on the slide here, it does say, is it a big deal? Well, I think it probably will be. Power over Ethernet has the capability of delivering both power and communication to all the devices that are connected. Often this is just utilising Cat 6, Cat 7 cables. And the reason why this is important is because nearly everything in our modern lives runs on DC. And internally or via a small plug-in charger, like your phone charger or your computer laptop charger, they're then converted from AC to DC. This is very, very inefficient, and it results in lots of devices all converting AC to DC. And pretty much everything in your home, apart from your microwave, your cooker, your hob, and your electric shower, washing machine and dishwasher, runs on DC. Everything around you, your TVs, your audio equipment, your LED lighting, your computers, your IT stuff, all your chargers, video surveillance, and your alarms is all DC, with everything being converted internally. So if you were able to have a connection, it would make life a lot easier, especially when lots of the on-site generation, such as solar PV, is generating on a DC basis. So with Power over Ethernet, I mentioned that it can deliver all the power and the communication, but importantly, it can deliver up to 100 watts, and that is more than enough for your TVs, laptops, cameras, etc., etc. It can link into USB-C connection points, which most laptops and phones use to charge. It's a single cable for all this. It's more efficient in energy use. It reduces resources such as these additional chargers, and it's safer. It will only provide up to 57 volts DC, so you're not going to have fatal electrocutions. And this voltage is selectable by the device, so it's available on there, and a device will link in and go, oh, can you send me 48 volts? Thank you very much, and here you go. So it can work with anything, and it's a really good potential solution for our future buildings. And I would pin this as a top thing likely to happen in the next 5 years. We're already seeing PoE enabled TVs and monitors in Southeast Asia, and I think it will only be a matter of time until this starts to filter through for the rest of Europe. On the screen here, you've got a couple of depictions on how PoE would work for some of the devices, particularly like the lighting and the blinds. So you have a module which you have the PoE, the Cat6, Cat7 cable connected into, and then this can be used to power the devices and also provide the data, etc., backwards and forwards. Another thing which is pretty obvious, to be honest, on-site generation. Solar PV, most people probably thought that, okay, once the feed-in tariffs had disappeared, it may halt the growth of PV in the UK, but solar PV installations are now back higher than they were before the feed-in tariff was abolished. You can see the growth chart on the screen, and residential and commercial is growing 14% each year. People still get smart export guarantees. They will be able to get paid for their exports between 5 and 11 pence per kilowatt hour, depending on what tariff and supplier they're with. And it's being increasingly specified for new builds and retrofits. Now, the user base for batteries has changed. So batteries obviously link in with solar PV, and the early markets did only focus on clients that had solar PV coupled systems, or clients that wanted a backup power supply. They may have lived in areas of sporadic supply, or they may have had mission critical or health critical applications. But as with everything, we are in a very changing world, and our energy systems are also changing. We now have things called time of use tariffs. So this is where it's a variable price being commanded at different times during the day for the electricity, depending on how in demand it is, obviously. And so this is enabling people to make use of this. You've also got linking in with this things called virtual power plants and energy aggregators. These are third parties that will kind of do the bidding and take control of the pricing, etc., enabling users to buy energy when it's cheap and sell it back when it's a higher price. So people can make money like the stock exchange by buying and selling energy at the right time. They could use it just for their own use, or they could use it in this kind of energy market. So really, users don't need to have solar PV to benefit from batteries. And the demand for this sort of thing is growing. We're seeing distinct growth for this, but especially with the energy price spikes as they're going on at the moment. You're also getting things like Plunge pricing alerts. So this is from Octopus, and these are notifications where particularly this time of year, when there's a lot of excess energy on the grid during the evening, customers will get notified that they will be paid for any electricity that they use. So if they've got a battery, it's a really good opportunity to take on energy, get paid to store energy while there's an excess of it, and then they can use energy for nothing. Well, they're being paid to use energy when they need it, or they can sell it back, particularly at times between 4 and 7 in the evening, when these flexible price tariffs can be extortionate. So there's some good money to be made and some good. So there's lots of different types of batteries, different sizes, shapes, etc. Most of these are stackable. You can get cabinet offerings, and you can get AC and DC connected. Now, moving swiftly on to the electrification of heat. We know this is top of the government's decarbonisation programme, moving away from fossil fuels. Hydrogen really is not the panacea and can only be classed as green if it's made through electrolysis using excess renewable generated electricity. But it's far more efficient to use electricity direct. This is probably going way off track here. But yeah, we have the solutions for heating through electrification here now. We don't have the time to wait for hydrogen. Don't get hoodwinked. So with the electrification of heat, we have the option of heat pumps. Everyone's talking about this quite a lot at the moment. Really efficient. Pretty much for every kilowatt of heat you put into the system, you'll get 3 to 4 kilowatts of heat out. And the intention is that 600,000 of these will be installed every year by 2028. And we're increasingly seeing the electrical sector being used for these installations as trades start to converge. And there will be upfront funding available from next year through the boiler upgrade scheme, which is going to help the adoption of sales of these. There's also other options such as air-to-air heat pumps, which offer heating and cooling as well. Simpler to install, and there's no wet. Now, historically, direct electrification of heat has been curtailed through energy performance certificates. This was due to old methods of electricity generation, which were quite carbon intensive. But our grid has decarbonised a heck of a lot since that was originally done, and the new changes in building regulations should take account of our greener grid, and will start to make electrification of heat appear better on energy performance certificates, EPCs. So they're the certificates that you get. So a couple of examples of direct electrification of heat. You've got smart storage heaters. There was a new regulation came in a few years ago, Lot 20, so these are very efficient and also welcomed by DNOs as they help to provide flexibility to the network. You've got infrared panel heaters. They can be hidden behind artwork or made to look like artwork, and they help to heat the components within a room as opposed to the air. And also you have got, it says infrared panel heaters on the right hand side there, but that's actually meant to be an electric boiler heater. So lots of different options into lots more new builds. We are seeing a number of projects doing these already. There was also a change in the eco-design regulations for lighting last month. So most halogen lamps are now banned. They were expensive and very inefficient. You have got traditional fluorescent lighting will be banned from sale from September 23. And because of all these changes, we do expect to see a shift in demand from our members and installers who are fitting out and upgrading particularly commercial premises. So this is certainly something for you guys to be aware of. EV charge points, obviously exponential growth at the moment. There is still funding available, so we are seeing a lot more members installing these by default. And a lot of these units do require an additional open pen protection unit. So this goes in series between the charge point and the consumer unit and provides additional protection, mitigating against an instance called open pen. And there's also special cabling now, which incorporates data and power for EV charge point installations. And we are seeing a number of our members using this as well, because you do need part of that prosumer kind of aspect, being able to control when these charge points come on and off, and remote connect. Briefly, commercial energy efficiency, power quality and smart controls. With this net zero carbon push, lots more commercial premises are becoming more and more efficient, and they're looking at their energy usage. And this is also becoming an increased requirement in parts L&F of the building regulations. And again, with the price. And so we will start to see deployed more building automation smart controls. Similar things like we looked at before with the blinds, lighting and windows, mechanical ventilation, heat recovery, more energy monitoring, energy generation and storage, and replacing old outdated motors, heating and HVAC. Ready for. Also, you've got the health and well-being side of things. This is increasingly gaining focus. There's new British standards 40101 and 40202 coming in on this, and this just shows some of the benefits of having a healthy and having a healthy workspace. Sorry, trying to record this on the fly is proving a little bit confusing. And yeah, there's a real good case for people having a healthier environment, and you can see it makes people more productive, it makes people sleep better, and so in conclusion, the world is changing, and so are the opportunities. There's many options available for the electrotechnical contractor and their suppliers. The opportunities here are not exhaustive, and things will continue to evolve. Combinations of measures will be needed. This will be on-site generation, battery storage, heat pumps, EV, smart controls, etc., etc. The retrofit works will be immense, and ECA believe that wiring systems within a building should be considered as part of the deep retrofit going forward, which will see replacement and changing of obviously the existing wiring systems and their ancillary devices. And as businesses pivot to deliver green technologies, we will see an increasing crossover of trades. I have gone over by 1 minute. Do apologise for that. Do enjoy the rest of the show. And if you feel willing to sponsor me, I'm doing a trek for the Inca Trail next year. It's been postponed by 2 years. Scan that code and send a donation. It will support the electrical charity. Thank you very much. Goodbye.